lecture for today. I want to welcome you to this lecture, and we're going to be looking at the common network devices. Yesterday, like you have all said, we looked at some of the common networking concepts, the different protocols, the different layers, OSI model, TCP, IP, and those different things, terminologies that we use in networks, DNS, FTP, and the different port numbers that they use, and also looked at a very important aspect, which we call the quintuple, which looks at the source IP address, destination IP address,
Mic check.
protocol, the source port, and also the destination port. Yes, please.
I realize we are still having recaps. I thought maybe you had started a new topic because I'm not seeing anything on the screen. The slides are not there on the screen.
I started a new topic, and I think I'm sharing the slides. Aren't you guys seeing the slides?
No.
We are seeing the slides.
Yeah, we are seeing it.
Please, you just
network devices.
Yes, you just need to be careful because also these interruptions are not good for the recording. I am sure I'm sharing the screen. You just have to look at your Zoom and see where you are also, and try and pay attention to what is happening around. All right, so and now today we want to focus on common network devices and also try and understand, after looking at the concepts and the different underlying protocols and everything, I want to look at some of those devices that are common today. And I believe we shall utilize, the expertise of some of the network engineers of this forum. So moving forward, network devices are the basic components of a network, right? They're the components that make up a network. And when planning and constructing a network, you need to deploy and configure network devices to meet or to meet security requirements. Agre, could you please mute the microphone? To meet the security requirements. So upon completion of this course, you'll be able to describe Huawei common network devices, and of course also other network devices. You also be able to describe the functions of a network device. What does it do? And you also log into a network device and perform some basic kind of configurations. So let us look at some of the basic network devices. This is a typical campus network, or even an enterprise network, and we have employees who are remotely logging into the services, trying to access maybe a server somewhere from the office. We have also another branch or even a partner trying to access the same resources. How are these guys being able to do that? We may find that we have quite a number of different things. We are going to look at a router in details, but on our network, you can see we have routers which are going to enable us to access our internet. And a router basically is a device for communications between or across network segments. We talked about that. We also have different devices like a switch, like you can see switches here, which connect now our access points. You see our end users are connecting to those switches, an IP phone, tablet, desktop, even our servers here. We can see that they're being connected with our switch. And we say that switch is a device for communications on the same network segment. Keyword, same network segment, or even across, sometimes different across segments, depending on the kind of switch that you're using. We have our anti-distributed denial of service, and we shall be looking at what distributed denial of service means, because there are some attacks that are conducted in that way, but we shall be looking at them in detail, and they are deployed at the network entrance in bypass mode, and it's an upstream of the firewall to reduce the firewall's packet processing load. We also have our next generation firewalls. As you can see, they are put here just before you access, our internal network. And basically, our next generation firewalls can also be deployed at the network, at the entry of the network, to provide preliminary protection or to protect our data center here from being attacked. We can have also virtual. Remember, this is security class. I was going to to tell you, remember, we looked at virtualization yesterday. But under normal circumstances, most organizations today utilize hardware resources by leveraging on the capabilities of virtualization. They have a server somewhere and they have virtualized it, and they have virtual machines running inside. Those are different physical servers sharing the same resources. So you can also have virtual network generation firewalls that can be installed on virtual machines, and they also have similar functions to like those functions of our hardware firewalls. We have our network, network intrusion prevention systems, and it's also a Huawei developed intrusion prevention and detection device that can also be deployed in our data center to make sure that it provides us, protection against intrusion. We have our different things. We have the agile controllers. We have so many other things that we can, place on our network to help us take care of some of those few things. So this is just a network, and we can have as many devices as possible. By the end of the day, it entirely depends on what you want to achieve as a network engineer. So that's why you choose to use some of the tools and devices that you may need for some of the devices that you may need to make sure that you have an effective communication. Okay. So we want to look at a switch. We looked at switches. We said we can have layer 2 switches, and sometimes we can have layer 3 switches. Yesterday when we were looking at different models. A switch, let me see if I can just pop up here a Google page, just so that we get a clear picture of how a switch looks like for those who have not done any kind of networking. Just to pop up some images. Wait, hey, these guys, how can they bring for me toys when I've searched for a switch? Okay, can you all see my screen, my browser?
Yes.
Yes, for those who have not seen a switch before, it looks like some of these devices you're seeing here. Depending on the type of switch, it has ports, and those different ports are what we are calling interfaces. And most of the switches today have gigabit Ethernet interfaces, right? So let me just pop up one. Which one can I pop up? Let me just pop up this or this one. Oh, I don't know why Google no longer pops up in the middle to display the picture very well. But let me, okay, let me just open a new tab. Okay. No, I'll not get what I wanted to get. Okay. So it could look like something like this. It has, these are different interfaces. Like this could be interface 00, 01, 02, blah, 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 blah. It also has things like console ports, yes, where you can directly connect to your console, or serial, ports where you can directly connect it to your PC and access it and manipulate it and use it. But basically, this is a switch, and it is used to connect, different devices or the same network segment, or it could even be across network segments. But basically, this is what a switch looks like for those who are unaware of what a switch looks like. So back to our concept, we are seeing that a switch works at data link layer. Data link layer is which layer in the OSI model, for those who are attentive?
Layer 2.
I check layer 2.
Thank you.
Layer 2.
It works at layer 2, and it helps in forwarding data frames. So this is what we are calling a switch. We have a switch A here, you have host A here, host B, host C, and if host A wants to send packets to host C. It will send the packets through the switch, and the switch will determine the interface where host C is connected. And you can see host C is connected on gigabit Ethernet 003, and then it will forward the packets on that interface, and then it will send it to host C. And then it will send it to host C. So as a number of users on an enterprise network increases, a switch can be deployed to provide a sufficient number of access interfaces, and also a switch completely solves the complexity of Ethernet by greatly improving the performance and security of an Ethernet. So yesterday, our friends told us that the switch also has the capability to learn, and we're going to understand how does it do the learning, and understanding the different MAC addresses of the hosts that are connected to its different interfaces. So a switch works as a data link layer, and it forwards data frames after receiving data frames. A switch forwards the data frame according to the header information. Okay, so let us try and understand the different forwarding states of the switch. So a switch can either okay, where's my pen? We're saying that the switch can either do flooding, it can do forwarding, or it can discard the packets accordingly. So a switch has a MAC address table, and the MAC address table stores the mapping between the MAC address of the host that is connected to it and the interface where that MAC address is connected. Okay, so we are mapping our MAC address together with the interface, right? With the interface where that host is connected. See, if this particular host here, forgive my drawings, is connected to the switch, and the switch has so many interfaces, and this particular host is connected to this interface, so it will have its MAC address table, and it will update it accordingly depending on the hosts which are connected to it. And we are saying that also sometimes the MAC address table is called a CAM table. It's called a CAM table, and the CAM table is what they call the content addressable memory table. As you can see in this picture, we can either perform flooding, forwarding, or even discarding. When it comes to forwarding, the switch floods the frames received on all interfaces through all other interfaces. I have my interface here. This is interface 1, this is interface 2, interface 3, interface 4, interface 5. When I say interface, now you all get the picture. Those are the ports where you're fixing the Ethernet cables. These ports I showed you here, right? These ports you're seeing here, 1, 2, 3, those are the different interfaces. Does that make sense?
Yes.
Yes, sir.
Those are the different interfaces. So in flooding mode, when a packet comes, the switch can choose, because when it doesn't know about the MAC address, it can choose to forward, because it doesn't know that host C is connected, let's say, to interface 5. It doesn't know that host C is here. So what will happen, it will just flood all the packets. For the first time the packet is coming, it will just flood to all the interfaces. But when the interface is received and this MAC address is not on that interface, definitely they will be discarded, and then it will be processed on this interface where this MAC address is. And then the switch will now understand, oh, I can now see this MAC address. Whenever I want to access it, I just need to now forward the packet to that MAC address. Let me just illustrate it again. So I'm saying it has the flooding mode. With a flooding mode, one, when it is flooding, it does not flood to its own interface, right? It will flood to all the other interfaces on the switch. Let's say our host C, the MAC address we are looking for host C is on this interface, right? So it's going to flood to interface 2, interface 3, interface 4, and interface 5 will all receive the packets. But since these guys are not the MAC addresses, they'll go ahead and discard the packets. So this PC now is going to learn that, oh, whenever I need to communicate to host C, his MAC address is attached to this interface 4. That's where his cable is actually fixed. The cable that is coming from this interface is where I can actually reach host C. His MAC address can be reached from that interface. So that is what is happening. So whenever next time and like let's say in the forwarding mode, whenever the user here wants also to send the packet to host C, which is on this interface now, interface 4, we also have what we calling the forwarding state. In the forwarding state, the switch forwards the frames received on an interface through another interface, okay? But it does not forward to its own interface, okay? It does not forward to its own interface. So because it knows that whenever I want to reach the MAC address of host C on interface 4, when next time a packet comes through, it will not flood now and to, exhaust our network resources. No, it will just go ahead and forward it to this interface. I hope that makes sense. And then the other mode is the discarding mode. Here the switch will discard the frames received on an interface. Let's say all these other guys, and the frame comes and maybe it's on a different, virtual LAN, let's say different VLAN, or let's say it's a different network, or let's say it's for MAC address that is not part of the interfaces. The switch can choose to discard the packet depending on the scenario at hand. So the basic working principle of the switch is that whenever it receives a packet or a frame in a unicast frame, what it will do, it will first go and search the MAC address table. Remember, we said the MAC address table maps what and what? It maps the MAC address of the host together with the interface where that host is connected. So it will go ahead and search. If it's in unicast mode, it will go ahead and search the MAC address table. And if the MAC address cannot be found, then the switch will flood the frame. It will search its table, and if it cannot find the MAC address, it will just go ahead and it will flood and send packets to 1, 2, 3, so that it tries to understand where that, where the MAC address or where that host is located. And if the MAC address is found, then of course it doesn't have to flood now, because it knows according to its mapping, according to its CAM table, this particular MAC address is mapped to this interface. Therefore, the switch will just go ahead and forward the frame to that interface where that MAC address is connected. Okay, and if it cannot be found, then therefore the switch or the frame will just be discarded. And if the switch now receives a packet which is in broadcast frame, we said broadcast, it is sending to how many? It is sending to all. So the switch does not check the MAC address table, because it knows this packet that I'm dealing with is a broadcast packet. Let's say it's an ARP, let's say it's whatever packet it may be, it will just broadcast. And the switch does not check the MAC address table, but it performs the flooding, because flooding means sending to all, and in broadcast mode also it means that you're sending to all. And upon receipt of the broadcast frame, the switch directly floods the frame without even checking the MAC address table. For the unicast, we said then it will go ahead and learn, also either update the CAM table, search the CAM table, and then it will go ahead and forward the frame. So initial stages of switches, we said in the initial stage, the switch does not know any MAC address, because it's new. You have just put it on the network. It has not learned any MAC address, and therefore the MAC address table, our CAM table here you're seeing, is what? Empty. There's nothing. But before receiving a data frame from host A, this switch MAC address table, because also remember, any device that is connected to the internet has a MAC address, right? So also its MAC address table contains no all entries for host A, and it has no nothing on it. So what is going to happen is that the switch has the capability to learn. Yes, it has the capability to learn. So remember, host A is going to go ahead and send a ARP request, because ARP, host A wants to learn of the MAC address of, let's say, host C or host B. So it will go ahead and send a MAC address table, an ARP request, and the ARP request will be in broadcast mode. Remember, the destination MAC address is full of zeros, so it's a broadcast MAC address. The source MAC address is this one of it, and of course it has also the source and destination IP address. It will go ahead and send it to the switch, and what the switch will know, oh, there's host A connected on this network, and host A, his MAC address is this, which is this one, right? 0001004AA. And whenever I want to communicate to host A, he's connected on this interface here, which is gigabit Ethernet interface 001, isn't it? So it also go and map those entries in his MAC address table. So the switch records the source MAC address and corresponding interface of the received data in the MAC address table. So after doing that, because we said it performs forwarding or even flooding. If it's in broadcast mode, it will flood. It will send packets to host B, and it also send packets to host C. So when the destination MAC address of a data frame is not in the MAC address table, or it is in a broadcast address, then the switch will flood the frames. It will flood, send to host B, also send to host C, as you can see, and then it will send them through this interface. Host B through gigabit Ethernet interface 002, host C between gigabit Ethernet 003. So now it has learned, because it has sent a broadcast packet, and this guy is the owner of that IP address, the unicast packets are going to be replied in an ARP reply, which is a unicast packet, and it is sending it back to A, telling it, oh, host A, by the way, you tried reaching out to me. I am on this address. This is my MAC address table. So it will reply. But in the process of replying to host A, because our switches are intelligent, like our colleagues told us, right? It's going to now to learn, oh, so this guy, host C, whenever I want to communicate to host C, he has replied via this interface, meaning he's connected on this interface, and this is his MAC address. So let me go ahead and update my MAC address table and know that whenever I want to communicate to CCC, his interface, I'll just forward the packets to gigabit Ethernet 003, because that's where I can be in position to access host C. I hope that makes a lot of sense. So we also want to look at the router. People were asking what's the difference between a router and a switch. And after looking at this, we shall be able to, to understand. The router works at which layer? People who were attentive yesterday?
Layer 3.
Layer 3.
Layer 3.
Yes. So a router is a layer 3 device, and
Layer
it's particular. And layer 3, what data do we send on layer 3? What we call the data that is being sent? Layer 3?
Packets.
They are called
Packets.
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 Okay. So the function of a router is to forward data packets between different networks. The keyword is different networks. So we have our, our application layer, transmission layer, network layer, data link layer, and physical layer. And the router here is mostly interested to working all the way up to network layer. Of course, it will go ahead and check the destination MAC, destination source MAC address, but it is most interested in, going all the way up to layer 3 to determine what is a source IP or what is a destination IP. So a router is a network layer device that forwards packets between different networks, as you can see in that picture. And host A and host B reside on totally two different networks. Host B is on different network. Host A is also on a different network. So when host A wants to communicate with host B here, upon receipt, host A will send a frame to host B, but upon receipt of this frame, the router that resides on the same network as host A will analyze the frame. This router here, which resides on the same network, it will receive it and it will analyze the frame. And at the data link layer, the router analyzes the frame header that determines the frame is sent to itself. Then it sends the frame to another, network layer, and then this layer here of router B, and then the network layer also, the router determines to which network segment the destination address belongs to, and then forward the packet such as the data frames until when it sends it to the next frame, to the next hop, which is B, to the next hop, which is C, until when it goes and reaches a destination. So it will cross-check through its details, check where the next hop is, check its routing table, and it will be able to know that whenever I want to communicate to host B, I need to go through these hops. So a router will select an optimal path for the data packets and forwards the packets. Yesterday we looked at one of the application, which is a trace route, and we said it also uses a time to live value to determine the hops that are on the network, and we say the default value is 1, and whenever it's passing through, whenever it's passing through a layer 3 device, it will be decremented by 1 until when we actually come to determine the number of hops on the network. So after receiving a packet, what also the router does, it selects an optimal path according to the destination IP of the packet. Please mute your microphone, or Gova, you have quacking noise in the background. Thank you. So the packet will be forwarded to the destination host. So the transmission of the data packet to the network is similar to like the way you can be running a rally, a rally race. You run, after running your part, you give the stick to your, your other, colleague to also run their part. They also go ahead, run until when they get to the next point, give their stick to the next guy until they also run and give, depending on the number of hops that are on the network. So each router will forward data packets to the next hop router according to the optimal path, and the packets are forwarded to the destination through the optimal path. In some cases, because certain routing policies are implemented, like maybe you're going to choose the bandwidth, you're going to look at the protocol that is being used, that also may not be able to determine. But a router can determine the forwarding path of data packets, and if multiple paths exist to the destination, the router will determine the best hop or the optimal next hop according to the calculations specific to the routing protocol in use. We are not in networking, so we shall not delve so much in the networking protocols. And now we want to look at the firewall. The word firewall came into existence and was first used in the construction field, where the primary role of the firewall was to isolate and prevent fire from spreading into the city. They would build a wall and they'd be like, in case there's fire here, we should build some wall that will help us prevent the fire from spreading within the city. So that's why the network engineers decided to come up with this concept of firewall. And a firewall is usually a device that is deployed, to meet certain requirements by logically isolating networks. So it logically isolates network and protects them from, various attacks on a network, and it also allows normal communication of packets to pass through. In communication, a firewall is usually mainly used to protect one network area. Like you see this network area, this branch area is being protected by this firewall. Also, this this area here of headquarters is being protected by this firewall. Also, this area here is being protected by this firewall, and also this one is also, the data center is being protected by the firewall. And you can see all these ones are connecting to the internet, but all of these guys are protected by the firewall. So we are saying it helps to protect one network area against attacks and intrusion from another network area. We don't know what is happening here in the network. There could be hackers here. There could be, intruders. There could be malicious guys. We don't know what is happening. So let us deploy firewalls at the egress of our network to make sure that we protect our networks from these, intrusions and from the, different network attacks that could be initiated. So because of its isolation and defense capabilities, it can be flexibly applied to network borders and subnet isolations, like you can see in this illustration. That is what we're calling a firewall. A firewall, they are different from routers and switches, because a firewall, because a router is used to just connect different networks and ensure that interconnection through routing protocols so that packets can be forwarded to the destination is achieved. Whereas like a switch, like I told you, a switch is usually used to deploy or to set up a local area network. Basically your LAN, and serve as an intermediate hub for LAN communications. You're just connecting either end devices or connecting devices together, and you're going to use your switch. And a switch will just forward packets through layer 2 or layer 3 switching, if it's a layer 3 switch. And a firewall, in this case, like you can see here, it is deployed at the network border, like at the entrance of your network, to control access to and from the network. Security protection is the core feature of a firewall. Its main role is to offer protection, and the primary function of routers and switching for them, they are to forward packets, and whereas the firewall for it is to make sure that it controls packet forwarding, make sure that there are no Trojan horses and viruses, etc. But for the router, it will do the addressing and forwarding and ensuring that network interconnection, whereas the switch for it are basically aggregating and building a LAN, your local area network, connect different devices together where end users can connect and share resources, blah, blah, blah. So those are the differences. So the primary function of a router and switch is to forward, whereas the primary function of firewall is controlling and making sure that it protects our network. So the firewall development history, I think from about 1989 to 1994, firstly, they were looking at packet filtering. They're looking at packet filtering, and they went to agile, application agent. They went to status check, and here they looked at mainly session, mechanism and proxy technology and access control. From about 1995 to 2004, they looked at multifunction overlay, dedicated device, and DPI technology. And from about 2005 2009 even to present, basically focusing more on control-based user application plus content. And this is where we're looking at the next generation firewalls. Okay, so the firewall has the different security zones. We have basically 3 security zones, but sometimes there are 4 security zones that we're going to briefly talk about them. Like you hear the word zone, zone, it is like a place or something. And security zones are what we are going to use to help us implement our security policies. Now, security policies are implemented based on these zones. Like if people are living in Kampala, they should not move and across the current state right now. They should not go to other districts. So also now, our government here in Uganda is trying to control the pandemic per zones. They're saying that people of this zone, people from Bara, people from Toro, people from what should not cross, they should stay in their inter districts. Those are the different zones. So also, government can also go ahead and say, according to this zone, maybe let us allow, put there some security policies. People should not move past this time or this particular zone, because there are no cases. Actually, saloons can open and maybe public transport can also work, but within only this zone, because this zone is not really affected with COVID. So here, the same analogy applies. And firewall security zones, we can use security policies, and security policies are implemented bossing on these different zones which are going to look at. And data flows in the same security zone bring no security risks and therefore require no security policies. If data is just flowing within the same security zone, because it's already the same security zone, some people are just moving within that area, so it's okay. We don't really need to come up with different security policies. And the firewall performs security checks and implements security policies only when data is now transversing and flowing from different zones as configured. So all devices on the network connected to the same interface must reside in the same security zone, and one security zone may contain the networks connected to multiple interfaces. Now we have these zones. We have the untrust zone. The word itself also speaks a lot to itself. The word is untrust zone. We have our untrust zone. The untrust zone meaning you are already in the untrust zone. We have the trust zone. Basically, this is the trust zone. And we have the demilitarized zone, the DMZ, usually our data centers and servers and all that. And also we have our local zone. The local zone is usually the local zone, the zone inside our firewall. And we shall look at them in detail. But all devices on the network connected to the same interface, like I said, must reside in the same network zone, and each security zone may contain networks connected to different multiple interfaces. And the interfaces can be either physical or they can be logical. I hope that is okay. So users on different network segments connected on the same physical interfaces can also be added to different security zones by using logical interfaces, such as using VLAN or VLAN if. Okay, so here we have our different zones. We have this on this interface, gigabit Ethernet. They're all connected to this interface, gigabit Ethernet 002. We have our demilitarized zone. So all these guys that are connected to this interface can be put to this one zone. Also, all the devices that are going to connect from the internet and they're connecting through gigabit Ethernet 002, we can now say everyone connecting from outside our network is going to be in our untrust zone. And we can have our trust zones, and we say everyone connecting from gigabit Ethernet 000, let's say the management interface, and also all the ones connecting from gigabit Ethernet 001, they are all coming from trust zone. So let us look at the basic initial login. We're not going to take a lot of time on this, but when it comes to when our time next week for our labs, this all will make a lot of sense, but let me just go through it briefly. Now we have VRP. VRP is a network operating system for Huawei devices. It's a network operating system. It is used by Huawei routers, switches, service gateways to implement network access and interconnection services. It provides a unified user and management interface which implements control plane functionality and also defines the interface specifications of the forwarding plane. Basically, its role is to manage the different Huawei network devices, and it also implements a network interface layer to shield the differences between the link and the network layers for each product. So it's a network operating system, a software platform that supports multiple types of devices and also provides TCP IP routing functionalities. So we have these different kind of ways we can log into our interface. Maybe let me just pop up my ENSP so that we understand. So I have my ENSP here, and it's a virtualized simulation tool for Huawei. And we can, let's say I have my firewall. Let me just use a switch because I think it will load faster. We shall not have to wait a lot of time to. So we have our switch here. If I go ahead and I start the switch, this operating system you see starting here is what we are calling VRP. It is an operating system that is going to run our what? Our switch. And as you can see now, our switch has started working. The very first view is user view. If you see the switch or any device that you are using to operate, I know that things are tiny. I don't know how best I can make them bigger. Okay, yes, I can make them bigger. Okay. All right, so we are saying if you are seeing when they are, these angle brackets, that's the user view. And basically the user view here, you are just, passing their commands, just visiting to see simple commands, blah, 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 blah. So if you want to go into the configuration level, then you need to enter into system view. And to enter into system view, you can just type this command and say either sys, or you can finish it and say, if you have a lot of time, and say system view, and then you'll be able to enter into system view. So now when you enter into system view, just like you see these brackets now, they have changed into a square bracket. That means you are into system view and you can be able to pass now configuration commands for the system view. If you want to enter into the interface view and you want to see the interface view, you can just go ahead and type in the interface you want to enter to. Let me say now I say interface gigabit Ethernet, gigabit Ethernet 001.001 or 2, and then you are now in the interface for gigabit Ethernet interface. That is the interface where we are. And when I say now display interface brief or display IP interface brief, then it will be in position to show me this is the interface brief. I have not assigned any IP address to it, and it is down because I have not connected any link to it. So basically, this is VRP, and I'm using it to manage my switch here, which I have powered on and which I have started. All right. So moving forward, I'll just minimize this and move forward. So basically, these are the command lines. Some of the commands I've been putting there, and I'll share this material. Kindly just go through them. But there are different commands which you can use either to delete, display, to find where different things are stored, to find out the info or the information center about the word, etc. This is how you configure or add a security zone. You go to the network interface and select interface to be modified, and then you add an IP address, and then you go ahead and add that network to it. You can also choose to add a static route onto it. You can just go into your command management console, and then you go ahead and configure these things. They're a bit direct forward, but when you get there, you get an opportunity to actually go through the PDF and try out some of those things yourself. Now, logging into device management, we can log into a device. Either we can use the console. We can either use the console. Someone, please, you have a very quirky noise. If your microphone is unmuted, please go ahead and mute. I don't know what's wrong with just muting your microphone if you're not speaking. I just don't understand. I really don't understand. So we also have Telnet. We have SSH, we have web. So we can log into our device. We can use the console port, connect to the console port and use the console cable, and then we are able to connect to our device. We also have Telnet, where we are going to use port 23, and then we will remotely log into our device, and then we can be able to, pass on different commands. We have SSH, and this is the login mode. Users use secure transmission channel to enhance security of data exchange. It provides a powerful authentication function to ensure information security and, protect devices against attacks such as IP spoofing. So also you can use that. And lastly, we have the web access, and through the web browser on a client to control and manage some of those devices. And we shall be looking at some of them later on. So how to log in through console port, you just go to device manager, blah, blah, blah. But we're not going to focus on some of those things because we're going to focus on how we can log in using the web browser. And web login, please pay attention to this. When you are going to log into the web, all you need to do, by default, you can log into your browser through the gigabit Ethernet. The management console port is what we are calling gigabit Ethernet 000. Okay, and the set IP address, obtaining network mode for connection of the IP address automatically on the administrator's IP. Directly connect the PC interface to the default management interface of the device or connect them through a switch. And the default management IP address, for our firewall is 192.168.0.0, and we can use this IP address to access our firewall from the browser login. And we say the default username is admin and the default password is admin at 123. So this is the simulation. We're going to simulate this firewall later on in the coming few slides or lectures. But we say the default management port interface is that 000, IP address 192.168.0.1. The default username is admin in lowercase, and the password is admin with a capital A at 123. Now, how we can be able to manage some of the service traffic. After you're able to log in, you go ahead and configure, a web login and configure a permit, HTTPS service, blah, 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 and so on and so forth. You can also configure administrator viewer so that the administrator can be able to log into the website. And after logging in, you can choose to accept and configure other things. Telnet login, we're also not going to focus on it, but I'll share the material. You can go ahead and go through some of this material at a later date. Okay, so the basic system configurations, overview of device file management. I'm also not going to go through device file management, but you will read through them and see how you can upgrade, click on upgrade. Some of these things are a bit direct forward. Log into the portal, go to system update, click on system upgrade, and then select where you want to browse from. And I will not focus so much on that. Maybe before I go to the last page, I'll just maybe try and access the firewall and see how we are going to be able to do it in the later videos. So we have our ENSP, and I'm going to delete this, and I'm going to come here to firewalls. And after I come to firewalls, I'm going to go ahead and add their firewall, the next generation firewall. Or Paul, please mute your microphone. I'm going to go ahead and put there this cloud. Please, I'll share the videos and the material on how you can do this. For now, don't worry. Or Paul, please mute your microphone. And then I'll go ahead. As you can see now, when I try connecting to this cloud and I connect to this interface and I try connecting to this cloud, it cannot connect because I have not yet configured any interface on it. So what I'm going to do, I'm going to go ahead and open this cloud. And I'm going to set my things to gigabit Ethernet. I already created a loopback interface, Microsoft Virtual Adapt on my PC, but I'll show you a video how you can be able to do that later on. So for now, no worries. So I'll just go ahead and add this interface there. And after adding that interface, I'll also add a UDP interface, gigabit Ethernet. And then I'll go, let me first, make it public. I'll go ahead and add it. And then after, come here, select number of ports. I select 2. Remote ports, I select 2. Two-way channel, and then okay. Go ahead and add, and then close. So when I now come and I try to connect my firewall, who can tell me what interface should I connect it when I want to manage it? What is the default management interface for my firewall? Those who are paying attention.
Gigabit Ethernet 00.
Gigabit Ethernet 00. No available ports. Oh wow. Gigabit Ethernet 00.
00.
Okay. Wait. Let me move this and put it back again. Gigabit Ethernet. And UDP. Okay. So connect on gigabit Ethernet 002. And then I will have to import, when I share this, you will have to import a configuration file. How you import for the firewall, you go ahead and right click, and then you say import. I will share the files with you. I'll share the files with you. When you see them, you download them, and after you navigate to where you put your downloads. In my case, I'm going to navigate to downloads. My computer is acting up. Okay, let me go ahead and say import. And then this PC, go to downloads, go to ENSP. The configuration file looks like this. The VF configuration file, select it and say open. And then wrong configuration file. Okay, let me see. Did I select the correct firewall? Just a moment, let me delete this. and put there this. Hope it's a correct one. Connect to that. Go ahead and import the configuration file. Okay, I think I already imported it already. So what you do, I'm going to go ahead and power on. I've selected everything. I'm going to power on the devices and they're starting. Okay, after starting, I will open my firewall console. It takes some time. It's going to hash and hash and hash until when it is ready. It's going to hash and hash and hash. We wait for it as it hashes. I'll share a video how you can be able to configure all those things. So do not worry. How you'll be able to configure everything. It's hashing. Okay, taking longer than usual. We can wait for it. And in the meantime, as it's hashing, let us be okay, boom, we are here. It has finished booting up. Like I've seen, it takes some time. Recover configuration began, ended, and then now the device is up and ready and running. Now we said here that for what was our default login?
Admin.
Admin.
We said it is
Admin username.
Admin in small letters.
We said
Admin with small
lowercase.
a, then password, admin with a uppercase.
we said it is admin. Let me try to make the words bigger so that I don't strain your eyes.
I think it's admin with
Admin in lowercase.
You said the username. Oh,
Admin in lowercase.
Admin lowercase.
I've changed the network, so I'll have okay, let me do the configuration again. Lower what?
Lowercase.
Lowercase.
Okay, just let me put the device there again. Just changed some few settings on my firewall on my PC. Okay, it is taking forever. So as it's finishing up, let me
Maybe it's like Google Chrome.
maybe it's what?
Google Chrome.
you don't like Google Chrome.
It's a program.
It is a RAM.
Yeah.
Excuse me, sir.
Yes, please.
Where will we find those recorded videos?
I am going to share, worry not, but most likely next week when we start working on these things. So I'm going to put there my firewall. I need to come back here and configure, give an ENSP. I created the loopback adapter already. Oh, sorry, I need to first delete this. It's meant to be gigabit Ethernet. Come here, select my ENSP, add it. Come back here, select UDP, add it, then select gigabit Ethernet, and then remote login, add two-way shake, then add, then close. Then come connect. Which port do I connect here? On my firewall?
0/0.
0/0/0.
0/0. So I'm going to go ahead and select everything here and start it. And as I start it, we just need to come back here and we complete this slide because it's going to take some time while starting. Okay, so I'm going to come and display this quiz. So quiz, what is the default login IP address used in web login mode? Let me enable.
It's A.
A.
It is
A
A.
is answer.
Yes, it's
Yeah.
192.168.0.1.1.
The answer is A.
The answer
It's
is
A.
A.
Yeah.
Okay. All right.
Yeah.
Thank you. The answer is A, and we have looked at the functions and model of a common network device. We have looked at device login methods and basic configurations of security devices, and we have looked at that. So I will navigate away from that, and it's still hashing. As it's hashing, let me see if we can also look at the common information security threats. In the meantime, okay, let me first stop recording.